Welcome students to part 3 of the video on section 9.1. It is 78 degrees outside and summer's getting close, so hang in there guys. We are almost done. You can do it. All right, so this next little section is kind of exciting, has some really cool notation as you can see. So one of the things you're going to want to do in calculus when you have some sequences is you're going to want to add up the terms. Either a finite series of terms like the first 10 or an infinite series of terms like all of them. And what you're going to do that is called sigma notation. Sigma, S-I-G-M-A, is the Greek letter S, basically. The capital sigma looks like this. Excuse me, the small sigma, but a capital sigma looks like that. That's basically a capital S in Greek, and it means sum. If you look at Excel or a spreadsheet, you will see that symbol, and basically all it does is it adds up a whole bunch of numbers. So here's a definition of the sigma notation, and it is a little confusing. So what I think the best way to do that would be to do 2 examples, and then you'll understand well what it means. So here's a first example. We're going to evaluate this. We are going to evaluate, whoa, I don't even know how to read that. All right, so let's take a step one step at a time. So the first thing you need to know is that this is called the lower limit of summation. That is this number. And this is called your upper limit of summation. And so what it basically tells you is that we're going to add together 5 terms from the first term to the 5th term. And we're going to add them together. So something plus something plus something plus something plus something. That is what we're going to do from the first term to the 5th term. Over in this one, we're going to add from the 3rd term to the 6th term. And in this one, from the 0 term to the 8th term. So in this particular case, all we have to do is basically this. We're going to plug in 1 in for I right here. So 3 times 1 is 3. And then we're going to plug in 2 for I. 3 times 2 is 6. Then we're going to plug in 3 for I. 3 times 3 is 9. Then we're going to plug in 4. And then we're going to plug in 5. And then we're going to stop because 5 is the upper limit of summation. So what this means is the sum of the expression 3i, where I equals 1, 2, 3, 4, and 5. And we're going to add them all together. So if you add all of these together, you get 45. And therefore, the answer is going to be 45. If you have a TI-84 calculator and you look around, you'll actually find a place where you can enter that. You've got to press math and you'll find it. It looks like a sigma. So let's try this one. So we're going to plug in the values of k from 3 to 6 into this k and then add. So it's going to look like this. 1 plus 3 squared plus 1 plus 4 squared plus 1 plus 5 squared plus 1 plus 6 squared. And stop, because 6 is your upper limit of summation. So this basically means 4 squared plus 5 squared plus 6 squared plus 7 squared, also known as 16 plus 25 plus 36 plus 49, which I did earlier, equals 126. So really, it looks complicated, but it's really pretty simple. That's all you have to do. All right. So for this one, it's kind of cool. I would actually, yeah, we'll do it. So the one thing you need to know is that by definition, and I don't know if you guys know this part, that by definition, 0 factorial equals 1. That's just something you need to know. If we were in class, we had time to tell you why, but just trust me. So let's plug in 0 for I. So I'm going to get 1 over 1. Then plugging in 1 for I still get 1 over 1. Then plugging in 2 for I get 1 over 2. And plugging in 3 for I get 1 over 6. Now, if you don't know why I'm doing a 6, think about it. That's 3 factorial. I'm getting 1 over 3 factorial, which means 1 over 3 times 2 times 1, which is 1/6. Plugging in 4, I get 1 over 24. Plugging in 5. Now, you might be wondering, why in the world is Mr. Peretti having me do this? Well, this one's actually really, really neat, and therefore I want you guys to see something. And lastly, plugging in, plugging in 7, and then plugging in 8. So now what I'd have you do, if you would, is pause the video a second, take a calculator, and add those up. See what you get. What you should have had, approximately, as a decimal, that is 2.7182 ... Do you recognize that? Uh-huh. That's correct. That is E. So that is exactly E. So really, oh, it's approaching E. It's not exactly E, excuse me. If I kept going, though, forever and ever and ever and ever and ever, it would exactly equal E. So really, we could actually come up with a cool formula that's really calculus-y, and it looks like this. If I take the sum from 0 to infinity, if I keep on going forever, of 1 over I factorial, it is going to equal E. And that is one of the really neat, short, succinct definitions of E. If you want to know more about that, you should sign up for calculus next year. They'll tell you all about it. All right, let's do on this backwards here. And let's see, we're going to write the following sum using summation notation. So let's see how many terms there are. 1, 2, 3, 4, 5, 6, 7. So I'm going to say that this is going to be from I equals 1 to 7. And let's see, what kind of formula is this? This seems to be linear. I'm adding 2. If there was a 0 term, it'd be 4. So I know that this is going to be 4 plus 2i. Let's test it. Plug in 1. Yep, I get 6. Plug in 2. Yep, I get 8. And so I know that I'm good. And that will be that sum. Now, there's more than one way to write that. You may have realized that. Who says that this is the first term? Could that be the 0 term? Sure. So watch. We could say, okay, I equals 0 to 6 of, let's see, 2i plus 6. Now test that. Plug in 0, you get 6. Plug in 1, you get 8. So there are different ways that you could write it. In fact, if you wanted to really think about it, you could even do this. You could say, okay, let's pretend that 6 is my third term, and I'm going to take the third to the 9th term of 2i. Try that. Plug in the 3 for I, you get 6. Plug in 4 for I, you get 8. And you go all the way up to that. So there's more than one way to write these things. This is not wrong, and this is not wrong either. However, it is traditional for your lower limit to either be a 1 or a 0. Usually we don't have the lower limit be a 3, but you could. All right, so that's sigma notation. There's really not too much to think about in this. It's just getting used to the notation, learning how to write it. So you have a few exercises on that. All right, lastly. Sometimes we are going to do what are called infinite sums. In other words, notice the difference. We're going to start from 1 and we're going to go to infinity. In other words, we're going to add them all. We're going to add every single term in this sequence forever. It is possible. I'll show you how. Before we do that, let's just make sure you guys understand the difference between a few things. There's some vocabulary. There's something called a sequence, and there's something called a series. A sequence is this: 2, 4, 6, 8, blah, 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 blah. A series in mathematics is very simply a sequence with plus signs in between it, where you're going to be adding it. So what we've actually been dealing with in this lesson right here are series. Sequence has commas and terms. Series has pluses, and you're adding them together. So what we're going to do in this one is we're going to do two things. Notice that this question here and this question here are exactly the same, except for here I'm asking you to find the fourth partial sum. So I want the sum of the first 4 terms only. And here I want you to find the sum. I want you to add up every single term all the way to infinity. It is possible. So here we go. Let's just find the first 4 on this one. So plugging in 1 first, I'm going to get 3 over 10. Plugging in 2, now you're plugging in 2 for I, so this will be 10 squared. So that's 100. Plugging in 3, that'll be 10 cubed, which is 1,000. Plugging in 4, you're going to get 10 to the 4th, which is, 1,000, which is 10,000. And that is going to be your fourth partial sum. It's partial because you're not doing all of it. Fourth because we're doing 4 terms. Now we can add them together. Now adding these together as fractions is a bit of a pain, but if I turn them into decimals, it kind of is nice. You'll see. So here we go. 3/10 is 0.3. 3/100 is 0.03. 3/1000 is 0.003. 3/10,000 is 0.003. And if you add those together, you get 0.3333. So that is going to be your partial sum. Okay, now what we're going to do is we're going to do something crazy. We are going to find an infinite sum of the series. It is possible to find the sum of an infinite series of terms. And we're about to do it. All right, so I know the first 4 terms. I know that it's 0.3. So the first term is 3/10, then 3/100, then 3/1000, then 3/10,000. The next term will be 3/100,000. The next term will be 3/1,000,000, and so on, so on, so on. You see what happens when you add that? It equals 0.33333333. Da, 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 da. In other words, it equals 0.3 repeating, or 1/3. That is really crazy. The idea that an infinite number of terms added together can equal a finite sum of 1/3. An infinite number of things added together equal 1/3. That is cool. And that is a lot of stuff that you're going to be exploring in calculus. You're going to be doing things out to infinity and realizing, oh, that's just a number. So to cut this a little short, I would encourage you to try this yourself and try this one and try this one just to make sure that you can do it. And I'll give you the answers. So on this guy, you should have had 0.5555. Can you get that? And on this one, you should have 0.5 repeating. 0.5 repeating, by the way, is also known as 5/9 if you'd like. Okay, you should be able to do this assignment. Once again, if you get stuck, just email me. I will seriously give you a hint. I will send you a picture of the work. I will sometimes even just send you the answer. So there's no reason you can't get 80% on this. We are getting close to the end, guys. Keep it up. You can do it. All right. See you next week.